Hello, chemistry. What am I thinking? Good lord. I'm on not even 10 seconds into this video and I've already made a mistake. Physics. Welcome. I'm going to talk about the calculations for your lab in this video. Now, you might recognize the board mess that is behind me. It's from the calculations for the coefficient of friction of the friction problem that I worked on in the last video, or a recent video. The reason I still have this up behind me is because this is how you do your calculations for your lab. The difference is that you know what A is. You have a mass sitting on the track, you have a hanging mass, and you have the string connecting the two. Both are accelerating this way, and there is a frictional force that way inhibiting them. So this is the calculation that you're doing for your experiment. The only difference is you know A because you measured it by you measured it in LabVIEW, and we calculated that, or we actually got that off of the graphs to have your acceleration. So this is the equation that you're working with, or rather, this is the equation that you're working with, where M2 is your hanging mass, G is G, and M1 is the mass of your block on the track. With the caveat, in part 3, where you increased the mass of the block, where you added those two metal masses, then it's no longer just M1, because M1 is the sum of the masses for the block and the additional metal mass that you added, and then later for the additional two metal masses that you added. So M1 stays the same in every calculation except for 2.3. In 2.3, it's going to increase for all of them. M2 is probably different in every single experiment because it's your hanging mass. So I guess you've got pairs for M2. But M2 is your hanging mass, G is G, M2 is the hanging mass again. A is the acceleration that you calculated from Excel. M1 is the mass of the block, or the mass of the block plus the additional metal bars. A is the acceleration that you calculated from Excel. M1 is the mass of the block, or the block plus the additional masses, and G is G. So this is the equation that you are using in order to calculate mu. Now, it is rare that you will be able to take exactly one equation from one problem and plug it into another. So be very careful trying to use this approach with other problems. You usually want to set it up where you're starting from here and rewriting new of these equations every time. Don't assume that you'll be able to jump to this all the time. This is the reason I did this problem for friction, so that I could use this as an example for your lab calculations. So that's it for this video. If you have any questions about your lab calculations, let me know, and I will try to help out with those. As always, I will still have the live stream available if you want to just tune into a call and ask for some help from 11 until noon every day this week. So just be aware that is an option that is open to you. So have a wonderful night. That's it for this video. Shortest video yet, I think. It's under 5 minutes.